Alright, this video is going to be all about sampling, and your learning target is I can sample data and analyze it. So you can be the researcher. Imagine you're collecting data on AP Statistics students. For this exercise, you will use the people in your own class. This is called a convenient sample. Well, because it's convenient. However, you're probably not in class yet because of COVID, so I'm going to make some stuff up. Okay, so let's pretend we were actually in class, and we looked at people's eye color, and this is what we found. So how many students are in the class when you collect the data? Now you're going to total them up. So let's say there were 23 people. If your class represents 1% of students in the United States taking AP Statistics, how many AP Statistics students in the U.S. have blue eyes based on your data? So the first thing we have to do, if we represent 1%, we got to figure out how many people would be 100%. Okay, so we would have to multiply 23 by 100 and get that there are actually 2,300 AP students. Okay, so based on that, we're going to try to figure out how many students would have blue eyes. So let's figure out what percent of our class had blue eyes. So we had 3 out of 23, which is 0.1304. So I'm going to say 13%. So now if I did 13% of 2,300, it would tell me how many AP students I would find altogether. So about 300. Oh, I wrote in the wrong box. Gosh. Alright. And then the last question says, how many male AP students have green eyes based on your data? Alright, so in our chart, let's see, we have 3 male students. Oh, well, that worked out nice. So 13%, and then 13% of 2,300 would once again be 3. So simple stuff like that. Alright, so now imagine that your AP Statistics class is the population of your survey. You want to take a sample, randomly pick 10 students and tally their data in Table A. Have those students return to the population, pick another 10 students and tally their data in Table B. Okay, so we're going to skip this just because I bet we're not going to be in school, so it's really not going to matter. So the last samples you took are called simple random sampling. Alright. Let's say you want to compare eye color by gender. Randomly selected 5 males and 5 females in the class. Tally the data from your samples in Table C. This one is called stratified random sampling. Alright. So there's a difference between simple random sampling and stratified random sampling. So if we were in school and we were all together and everybody was safe, we would actually do this. I'm going to assume that we're not. So we're going to skip it. Another way to sample is by location, which is called cluster sampling. So if we're in school, we're going to do this. We're not, so we're just going to move on. So let's just look at, we're not going to do the fun part. We'll just look at the boring part. So suppose you are conducting a poll to find out voter attitude towards gun control. There are 3 major ways you could choose to select your sample from the population. Okay. So we're going to look at what's the definition of simple random sampling, stratified random sampling, and cluster sampling. So for simple random sampling, the definition is each individual in the population has an equal chance of being sampled. So if you look at the visual, you had 1,000 people, and you would just pick 100 of them. Alright? The next is stratified random sampling. So for stratified random sampling, you would divide the population into strata, which just means a subset, and then conduct a sample of each strata. So like you could put those 1,000 people and you could put them into 2 different categories, men and women. And then from each group, you would take 100. So that's a little different. And the last one is cluster sampling. So the cluster sampling, you would divide population into geographic clusters, so based on location, and then you would take a sample from each of them. So you would take 100 from each. So that's the 3 different sampling methods. All right, then let's look at the advantages and disadvantages. So remember, this is my simple random sampling. This one is my stratified. I'm just going to put strata, and then this one is my cluster. Alright, so here are your advantages. So simple random sampling is meant to be unbiased. It's considered the fair way to sample. So for stratified random sampling, it accurately represents the population. It has greater precision than simple random sampling because you're dividing them into these different subsets. And then the last one is cluster. And the advantage of a cluster is that it's more cost effective. So it may be more feasible. Doesn't mean it's more accurate. It's not more precise. But, you know, money's money, and it's more cost effective. Alright, let's look at our disadvantages of each of them. Alright, so for simple random sampling, sampling error may not accurately represent... there could be a sampling error, and it may not accurately represent the population. Because you're looking at like a big whole picture. You can't see the trees because of the forest type deal. For stratified random sampling, the disadvantage is it can be costly, and it would be ineffective for populations that don't have obvious subgroups, because that's the whole point, putting them into subgroups and being a little more precise. Cluster sampling, less precise, has a higher sampling error, and it has a potential for bias because you are putting people in different categories, different geographic locations, so there could be some bias going on. Alright, so this is your turn. There's no math, just thinking, putting thoughts on paper and making sure it actually makes sense. So a researcher wants to collect data on entering freshman university students' top 3 major choices across the United States. The researcher plans on analyzing the information by gender, GPA, geographic location of college, ethnicity, and size of university. I want you to tell me, explain how the researcher could create a stratified random sample, explain how the researcher would create a cluster sample, and if you were the researcher, which type of sample would you select and why? I'm not going to say there's no wrong answer, because there definitely are, but there's lots of correct answers. And as long as you are looking at the definition and actually thinking about what it's supposed to look like, you'll be good. Alright, now let's try this one. Be the researcher 2. Imagine you're collecting data on voting affiliation. You find a list of voter registrations, no names, that is available to the public at your library. This is called a convenience sample, because it's convenient. You're going to cut out the voter registration cards provided. Those are in your notes. I want you to tally the data in the tables 1 and 2 below. And then you're going to look at it by regional location as well. So you're going to use the same cards. The first one, you're going to look for like how many are Democrat, Independent, or Republican based on gender. And then you're going to look at your region location based on gender. So take a few minutes and do that. Try that in 1, 2, 3. Okay, so this is what I got. I did not double check my math. So if I'm wrong, I'm wrong. Hopefully yours is good. So how many voters are in your symbol? I just added up the first table and I got 36. Alright, if this data represents 2% of voters in the United States, how many voters are Democrats? So in just our sample alone, we have that 15 out of 36 are Democrats. This is approximately about 42% of our data. So this represents 2% of the United States. So now we've got to figure out how many are actually in the United States. Okay, so here's what I do. So 36 was how many voters are in our sample. If I wanted to find like 30% is of 2%, I would do 36 divided by 2%. So remember to change 2% to a decimal. And when I do this, I get this big number. So this is how many people there are in the United States, how many voters. And then 42% of them are Democrats. So I'm going to do 42% of that number I just found. my final answer is going to be 75,600. Okay. The next question asks me how many voters are from the West Coast, so I just look at my chart. So there's 8 of them. So 8 in my sample. 8 out of 36 equals about 22%, and we'll do the same thing. So we know that it's like this many voters, which is probably not accurate. And then if we wanted to find 22% of that, we just times it by 0.22. And so you get about 39,600 voters from the West Coast. So that was just based on our little convenience sample. Alright, so now what you're going to do is you're going to take those cards, and that's going to be your total population. So 36 is going to be our population. And we want to take a sample out of that. So randomly pick out 10 voter cards and tally the data in Table A. So try that in 1, 2, 3. Alright, so here's what I got. And yours can be a little bit different. That's fine. It's just whatever you randomly selected. So return those voters to the population. So now you should have 36 cards again. And you're going to randomly pick another 10 voter cards and tally that data in Table B. So try that in 1, 2, 3. Alright, so here's what I got. So what's similar about the two samples? So really, as long as you make a logical thought, it should be okay. They both have the same sample size. I don't know. Something like that. What's different about the two samples? Different numbers, whatever you want to think about. And why do you think the samples were similar or different? So they were both taken out of a population of 36. They were randomly selected. That's why they were different. Anything you put like that will be fine right there. Okay. So then let's say you want to compare data by gender. So divide the cards into female and male piles. Randomly select cards proportionally from each pile to total 10 cards. So take an equal amount of each of them. So tally the data for your samples in Table C. And this kind of sampling by category is called, this is your cluster sampling. So they're divided into categories, and then an equal amount, 10, is going to be taken from each category. So try that and see what you get. Alright, so this is what I got when I did it. Yours are completely random, so they should be different. Each of them should total 10 cards. That's the only difference. So you can answer that first question, how does this sample compare to other samples you took previously? You could say there's an equal amount of male and females this time. I don't know. It's kind of up to you. It's spread out more if your data said that. It's even if your data says that. Whatever your data says. So how does the data for males compare to the original data you collected in Table 1? So once again, just a coherent thought. Whatever your data looks like is what you would say. And then what limitations do you find in the sample based on your population? So I would say it's kind of a little biased because you put them in male and female categories first, and then you took 10 samples, so you kind of put some bias on it at the very beginning, and then you picked your different categories. But any way you word that, it's fine as long as it's a coherent thought. Okay. And I just realized that I made a typo, and I'm going to blame this on pregnancy brain. I am completely brain dead. So number 3, that was not cluster sampling. That was not a location. Oh my goodness. That was your stratified. Okay. So your stratified random sampling was number 3. So number 4 is by location. Sorry, that's your cluster sampling. Cluster sampling is when you deal with like location, geographic location. So cluster sampling. My little Apple Pencil just died, so that's why it's so ugly. So you can just fill this out. I mean, you can look back at the notes we did. But really, any coherent thought is going to work. So those are your 3 different types of sampling that we talk about. We talked about simple random sampling. Talk about stratified random sampling and cluster sampling. So if you have any questions about that, let me know.